Okay, we're back, and it's Mrs. Allen, and we are looking at 5.1 Euler's method. We're just finishing up this lesson with video 2. So we went over the numerical approach that we're using by using the tangent lines, and we used the point slope form, and then we reevaluated the tangent line slope at a particular value on the function using just the derivative, and then built ourselves an approximation for the curve as we iterated each time. Go through the same process, inputting our output each time. Y2 becomes the Y3 input, and Y3 becomes the Y4 input, and so on and so forth. Okay, so we went through a couple of examples there, and then on example 1, we finished that up, and we got to example 2, and then the video cut out, so I kept what I had, and I'm going to pick up where I left off. So I think I left off with Y2. So in doing these iterations, you can kind of see, let me get the point here. So we start off, and we've got y sub 0 is equal to 3, so we're going to put that in here, and the delta x was negative 0.25. We had already calculated that. And then we're going to evaluate the slope dy dx is equal to 2x plus y at the point 1, 3 that we have in our table. So it turns out we put in our values. We have 2x plus y here. And so that gives us a y1 is equal to 1.75. Then that becomes our y1 in the table. And here's our new x and our y, okay? So then I go to the next value, y2. And you can see that I set up the formula again. I have y1 plus delta x times dy dx, and then that's evaluated at 0.75, 1.75, using that point. So plotting everything in here, plugging everything in. And then we have 2x, remember 2x plus y, just plugging them in. And it turns out that I end up with y2. y2 is equal to 0.9375. So it is kind of a mechanistic kind of thing. You do several and you kind of get it. So y3 is equal to y2 plus delta x plus 2x plus y evaluated at 0.5. You see 0.9375. And we get our value of y3 then, after plugging everything in. We get y3 is then equal to 0.453125. And that becomes our input for the y. And again, I plug that in right away just to make sure you have your values going into your table. It kind of keeps it easy to look back on then. Okay, and then I've got y4. And you can see I go through the same process, and I get y4 is equal to 0.214. And that puts you at 0 then. So at 0, the function value is 0.21484375, and we're going to approximate that at y4 is 0.215. So y of 4 of 0 because we got to put the x value in there. Y of 0, because remember we're going backwards from 1 to 0, is approximately 0.215. And there you have it. So what I'm going to do is I'm going to give you one more problem. You try it. And I'm giving you the value or the expression for the derivative is y prime is equal to 2 minus e to the negative 4t minus 2y plus, and the fact that you have that t sub 0, y sub 0 is equal to 0, 1. So that's your starting value. Delta t, and I find that to be pretty common with a lot of these problems. They try to keep it simple when you're first going through it, even on the AP exam. So delta t is equal to 0.1. I'm giving that to you. So I'm just showing you that you have your t values down there. They're the independent variable. So you still have step 1 is y1 is equal to y sub 0 plus delta t times y prime evaluated at 0, 1. That'll be your first step. And it turns out, as you can see down through the steps, you've got y of 0.1 is equal to 0.9. Okay, now then I'm asking you to complete 2 more iterations. So pause your video right now and see if you can do 2 more iterations. And remember, delta t is still 0.1. And I didn't build a table with this. You can build a table if you like. You'll see my answers in the end. Okay, so pause your video, and when you're finished, then check back. Okay, after you pause your videos, then you want to get through, there's your first initial step there where you're going to say y2 is equal to and y3 is equal to, put the structure down. You have the x values of 0.1 and then 0.2. So you'll get your y3. I just want 2 iterations. And here are the answers that you should have. So your approximation y sub 3 should be approximately 0.837. Okay, and that's it for this video. And I hope you have a great day. And remember, you can pause your video if you like and just go over those. But have a great day, and I will see you when I see you. Alan.